So today we are going to discuss about programming logic and design. So at the end of this chapter, you should understand computer components and operations, and you should know to describe steps in programming process and the data hierarchy, and you should know how to draw flowcharts and how to do pseudocodes and how to use and name variables and sentimental dummy values and how to end a program and how to use the connector symbol, assign values to variables and recognize the proper format of assignment statements and describe data types, and finally you should understand the evaluation of programming techniques. So at first we'll discuss about computer components and operations. So when we think about what is a computer system consists of hardware, software and user. So we are going to discuss about each of these components now. Hardware. Hardware refers to objects that you can touch like disk drives, display screens, keyboards, printers, boards and chips, or we can refer to hardware as equipment or devices. Software. Software is a set of programs which are step-by-step instructions telling the computer how to process data. The software can be divided into two groups: system software and application software. System software controls the overall operation of the system. It is stored in the computer's memory and instructs the computer to load, store and execute an application. For examples, we can give operating systems, translators, Windows, Unix, etc. Application software are software that written to perform specific tasks. The basic types of application software are word processing, database, spreadsheet, desktop publishing and communication. For examples, we can give Microsoft Office, Tally, Microsoft Outlook, ISBS, Modbanker or BankSoft. User. In computing, we can call an individual who uses a computer as the user. Okay, now we have major operations in a computer. Those are input, processing, output and storage. So we are going to discuss about these each operations separately. Input. Input accepts data from input devices and sends it to the computer processor. Common input peripherals include the keyboard, mouse, stylus, touchscreen, digital cameras, microphones, scanners and joysticks. Processing. Data processing is the most basic function of a computer. This function is performed by the Central Processing Unit or CPU, which consists of electronic circuits that can read and execute code instructions to perform a wide range of tasks, from performing complex mathematical calculations to sorting the entries in a database. Central Processing Unit or CPU consists of these following features. First, CPU is considered as the brain of the computer. CPU performs all types of data processing operations. It stores data, intermediate results and instructions, and it controls the operation of all parts of the computer. Output. Output communicates the result of processing to the user or display the output in several ways. Output peripherals include monitors, speakers, 2D and 3D printers. Storage. There are two storage categories, internal and external. Internal storage located inside the computer system, main memory or RAM, registers, ROM and cache. Some are volatile, that means contents are lost when the power goes down, and some are non-volatile, that means those hold data regardless of machine has the power or not. External storage, those are persistent, and auxiliary storage and secondary storage we can call as and that is, it is not inside the computer's main storage or memory located outside the computer system. For example, we can give floppy drive, hard drive, flash media, and magnetic tape. So next we will discuss about programming language. So language has been our primary means of communication and human interaction. For a community, the language contains the words that the people need to communicate. Words themselves are abstract, but they indicate the meaning, like they point to objects or actions and so on. When you look at your computer, you will find it's not so much different. There are many pieces of hardware and software that need to communicate with each other. Our application is reacting to the mouse and keyboard or even the mic. It can read files from your disk storage and so on. But at the end of the day, machine understands nothing but bits, that means ones and zeros, which called machine language. A programming language is the set of instructions through which humans interact with computers. There are special pieces of software that turn the code you write into machine language that the machine understands. The programming code is pretty much like writing a paragraph or instruction or creating a to-do list to computers. Like us humans, this to-do list and instructions you write for the computer have to be extremely detailed and written in some logic. With code and programming, you can get the computer to draw complex shapes and create rich computer graphics, and also create programs that understand game mechanics and help you build games that feel real with gravity and particle collision. With these programs, you can create the most intense and immersive games of all sorts. Syntax: the rules governing word usage and punctuation in the language. Programming syntax contains strings similar to words, much like a human language. Correctly formed syntax strings produce syntactically correct sentences with a specified programming language. In programming, syntax refers to the rules that specify the correct combined sequence of symbols that can be used to form a correctly structured program using a given programming language. Programmers communicate with computers through the correctly structured syntax, semantics, and grammar of a programming language. Machine language: a language that controls the computer's on-off circuitry. Sometimes referred to as machine code or object code, machine language is a collection of binary digits or bits that the computer reads and interprets. Machine language is the only language a computer is capable of understanding. Compiler and interpreter. We generally write a computer program using a programming language, which is a high-level language. A high-level language is one that is understandable by humans, and it contains words and phrases from English or other language. But a computer does not understand high-level language. It only understands programs written in zeros and ones in binary called machine language. A program written in high-level language is called source code. We need to convert the source code into machine code, and this is accomplished by these compilers and interpreters. So we'll see what are those compiler and interpreter. Compiler takes the entire program and converts it into object code or machine code before program runs, and it is typically stored in a file. For examples, we can give C, C++, and C#. Interpreter. Interpreters convert code into machine code when the program is run. Therefore, this is memory efficient. Examples of interpreted languages are Perl, Python, and MATLAB. Computer instruction. So you already know a programming language is a set of instructions we give to the machine to do a task. For example, we can say giving instruction for another person to do just about anything, maybe making a sandwich. The situation in computers is that they do what they are told and nothing more, so you need to give full detailed instructions. So we'll see an example of giving a machine some instruction to make a sandwich. First, take a slice of bread, open the butter tub, pick up a knife by the handle, insert the knife into the container of butter, withdraw some butter using the knife from the container of butter and run it across the slice of a bread. Put the first slice of bread on the cutting board. Take the second slice of bread. Repeat steps 2 to 5 with the second slice. Put the second slice of bread on another place of the cutting board or plate. Place a slice of bacon on the buttered side of the first slice of bread. Place a slice of cheese on the bacon which is on the first slice of bread. Take the second slice of bread and place the buttered side on the bacon slice which is now on the first slice of bread and cheese. In computer science, we consider these as instructions to the computer or the algorithm. Now we have a sandwich and this is the output of these instructions. Now you have a little exercise to do. Write the steps you follow when you brush your teeth. Errors. If you started programming, the first thing you notice is that things break and they don't always work as you expected. Even when they work, you might see that the output is wrong, or sometimes you are not allowed to run program, and sometimes the program stops the execution at the runtime or terminate the program. Those are called programming errors, so it is useful to know these errors. So we are mainly having 3 types of errors: syntax errors, runtime errors and logical errors. At first we will discuss about this syntax error. This happens when the code doesn't respect the syntax rules a program requires. For example, in C# or Java, if you omit the semicolon at the end of the line, that will confuse the compiler because it will not know that you mean anymore. So as a result, this will throw an error. So these are some errors that you can see in programming: spelling mistakes, missing out quotes, missing out brackets, using uppercase characters in keywords, missing out a colon or semicolon at the end of the statement, using tokens in the wrong order. For examples, think I ask you to make some tea and you don't even know what is tea. So here I have done a syntax mistake, a spelling mistake, and because of this, now I'm not going to have any output. So if I correct it and ask it again, make some tea, so now you understand what I meant, and now I'm going to have a tea as an output. Runtime errors. Runtime errors are those errors that appear unexpectedly while the program is running. These errors cause a program to terminate unexpectedly. Logical errors. As the name implies, these appear when the program runs but behaves not as expected or gives wrong results. That means you are not having the expected output. For example, an algorithm to run properly, the logic must be correct. We'll take this cake recipe as an example. Here in this recipe, first you have to add the ingredients to the bowl and mix well until it's smooth and uniform. Pour the batter into the pan. Put the pan in the oven and bake the cake at 180 Celsius for about 90 minutes, which will give you this, a burnt cake, this is not the expected output. So what is the wrong logic here? Here it is. You have to correct the last step as put the pan in the oven and bake the cake in 180 Celsius for about 20 minutes, not for 90 minutes. And this will give you the correct output, a perfect cake. And if you go to another example, think a student need to find the average of his test results and he writes the logic as follows. Average equals to test 1 plus test 2 plus test 3 divided by 3, and you know the results he is going to have is obviously incorrect. So to have the right output, the logic should be as average equals to test 1 plus test 2 plus test 3 and this whole sum divided by 3. So now this is the game time. Go to this website and play this Lightbot game and give some instructions to the robot how to walk. Thank you.